Welcome to session number 5 of matrices of class 12. 17th question. If A equals to matrix 3 minus 2, 4 minus 2 and I equals to, I means identity matrix 1 0 0 1, then find k value so that a square minus that equals to k minus 2i. From this given condition we can find the value of k, where matrix A is 3 minus 2 4 minus 2 and identity matrix 1 0 0 1. Solution: given matrix A equals to 3 minus 2 4 minus 2 and I equals to 1 0 0 1. The given condition is a square equals to ka minus 2i. That means a square means a into a, that equals to ka minus 2i. Multiply a 2 times, that is 3 minus 2 4 minus 2 into 3 minus 2 4 minus 2, that equals to k into matrix A 3 minus 2 4 minus 2 minus 2 into matrix I 1 0 0 1. Simply you substitute A matrix A value and I value in the given condition. Now you multiply these two matrices row column, that is 3 into 3 9 plus minus 8. First row, first column is over, minus 6 plus 4, 12 minus 8 plus 4, that equals to 3k minus 2k 4k minus 2k. Multiply this matrix with k minus 2 0 0 2, multiply with 2. Now this matrix becomes 9 minus 8 1 minus 2 4 minus 4. This is LHS part. Now subtract this matrix from this matrix, that is 3k minus 2, next minus 2k minus 0, 4k minus 0, minus 2k minus 2. Now these one subject here, these two matrices are equal, then their corresponding elements are equal by the definition of equality of matrix as the given matrices are equal, their corresponding elements are equal. Therefore 1 equals to 3k minus 2 minus 2 equals to 2k. Assume this is first equation, this is second equation. 4 equals to 4k third equation, minus 4 equals to minus 2k minus 2, fourth equation. From this first equation, we have only one variable here, k. Now, if you solve this equation, you transfer this 2 minus 2 to LHS part, then 1 plus 2, 3 by 3, 1. So, 1 plus 2 equals to 3k, that equals to 3 equals to 3k, then k equals to 3 by 3, that is 1. So, k value from first equation 1. Next, from second equation, minus 2 by 2, that is k. This is minus 2, no? Minus 2. So that equals to 1. Therefore, k equals to 1. From third equation, 4 by 4 equals to k. You transfer this 4 to this part. This 4 here, it is in the form of multiplication. So it becomes this side denominator. That equals to 1. Similarly, minus 4 plus 2, that equals to minus 2k. Minus 2 equals to minus 2k, then k equals to minus 2 by minus 2, that is 1. So k equals to 1. Therefore, k value is 1. Next question, 18th question. This is very, very important question. If a equals to 0 minus tan alpha by 2, tan alpha by 2, 0, and I is a identity matrix of order 2, then show that I plus a, that equals to I minus a into matrix cos alpha minus sin alpha, cos alpha. Solution. Here, matrix A is given, that is 0 minus tan alpha by 2, 0. And I is the matrix, identity matrix of order 2. 2 means 1, 0, 0, 1. Then, we have to prove that I plus a equals to I minus a into cos alpha sin alpha minus sin alpha cos alpha. That means LHS part is equal to RHS part. Solution. Given a equals to 0 minus tan alpha by 2, 0, and identity matrix I equals to 1, 0, 0, 1. Now you take LHS part, that is I plus a, that equals to I 1, 0, 0, 1 plus a, matrix A is 0 minus tan alpha by 2, 0. If you add these two matrices, you will get 1 plus 0, 1, 0 plus minus tan alpha by 2, minus tan alpha by 2, tan alpha by 2, 1. This is LHS part. Next, assume first equation. Next, RHS part. that is I minus A into cos alpha minus sin alpha cos alpha, that equals to I 1001 minus A, that is A matrix 0 minus tan alpha by 2 tan alpha by 2 0 into whole bracket, that is cos alpha minus sin alpha cos alpha. Now just clarify this inside the bracket, that is 1 minus 0 1 0 minus this value, that is positive value tan alpha by 2 minus of minus plus, next 0 minus this value minus tan alpha by 2 1 minus 0, that is 1 into cos alpha minus sin alpha cos alpha. Now you multiply these two matrices, row column. So 1 into cos alpha plus tan alpha by 2 into sin alpha, tan alpha by 2 into sin alpha. First row, first column is over. Next first row, second column, 1 into minus sin alpha plus tan alpha by 2 into cos alpha. Next second row, first column, minus tan alpha by 2 into cos alpha plus 1 into sin alpha. One into cos alpha plus tan alpha by 2 sin alpha, 1 into minus sin alpha. Okay, again this into this plus this into this. Next minus of minus plus tan alpha by 2 into sin alpha plus cos alpha. Next now once you observe here, cos alpha plus tan alpha by 2, tan can be written as sin alpha by 2 by cos alpha by 2 and take LCM. Now I am writing here cos alpha plus sin alpha by 2 by cos alpha by 2 into sin alpha. First term is over. Next second term, minus sin alpha plus sin alpha by 2 by cos alpha by 2. Just you convert tan value in terms of sin and cos alpha. Next here, same as it is, minus sin alpha by 2 by cos alpha by 2 into cos alpha plus sin alpha plus sin alpha by 2 by cos alpha by 2 into sin alpha plus cos alpha. Now here take LCM here. Cos alpha by 2 into cos alpha plus sin alpha by 2 into sin alpha by cos alpha by 2. Next, minus sin alpha cos alpha by 2 plus cos alpha sin alpha by 2 by cos alpha by 2. Next, second term, sin alpha by 2 cos alpha plus sin alpha cos alpha by 2 by cos alpha by 2. Next, here also sin alpha by 2 sin alpha plus cos alpha by 2 cos alpha by cos alpha by 2. Once you observe in all the terms, that is in numerator part, cos A cos B plus sin A sin B. Next, sin alpha cos sin A cos B cos A sin B, sin A cos B cos A sin B, sin A sin B cos A cos B. So these all the terms forms any one trigonometric formula, any one of the trigonometric formula. So we have the formula for first term, cos A cos B minus plus sin A sin B, that is cos A minus B. Cos A minus B equals to cos A cos B minus sin A sin B. For this term and this term, because cos A cos B sin A sin B, cos A cos B sin A sin B, cos A sin B sin A cos B, cos A sin B sin A cos B. So for this sin A minus B, that equals to sin A cos B minus cos A sin B. So simply you can write that equals to cos alpha minus alpha by 2 cos A cos B sin A sin B alpha alpha by 2 by cos alpha by 2 by cos alpha by 2 cos alpha by 2. Here sin minus of sin alpha minus alpha by 2 by cos alpha by 2. Next, similarly sin alpha minus alpha by 2 by cos alpha by 2. Next, this term, for this term, cos alpha minus alpha by 2 by cos alpha by 2. Next, you can write here alpha minus alpha by 2, 1 alpha minus alpha by 2, that is alpha by 2, cos alpha by 2 by cos alpha by 2 minus sin alpha by 2 by cos alpha by 2. Next, sin alpha by 2 by cos alpha by 2. Here also cos alpha by 2 by cos alpha by 2. Alpha minus alpha by 2, 2 alpha minus alpha by 2, that is alpha by 2. Now both the same terms gets cancelled, that equals to 1 minus of tan alpha by 2 tan alpha by 2 1, that equals to I plus A from equation Equation 1. Equation 1 is I plus A. Therefore, LHS equals to RHS. Therefore, LHS equals to RHS. Hence proved. That is I plus A equals to 1 I minus A into cos alpha minus sin alpha, cos alpha. This is our required proof. Very, very important question. Next. Nineteenth question. This is database question. A trust fund has rupees 30,000 that must invested into different types of bonds. The first bond pays 5% interest for a year, and the second bond pays 7% interest for a year, then using matrix multiplication, determine how to divide this 30,000 rupees among the two bonds if the trust fund must be obtain an annual total interest of first one 1800 rupees and the second one 2000 rupees. Once you read the question once again, a trust fund has 30,000 rupees. Total amount is 30,000. That must be invested in two different types of bonds. So these 30,000 can be given to two bonds. That means two persons. The first bond pays 5%. First person pays 5% interest and the second person pays 7% interest. Using matrix multiplication, determine how to divide this 30,000 amount among the two bonds if the trust fund must obtain an annual total interest. On this total amount, they got the interest 1800 rupees. 1800 rupees. Okay. Then how much amount given to the first person and how much amount given to the second person? First person pays 5% interest and second person pays 7% interest. Among those two persons, how much amount they were taken. That is solution. And both the person pays total interest 1800 rupees. 1800 rupees. Now, how much amount they were taken, that is I don't know. So just I am assuming the first person taken X rupees. Automatically second person 30,000 minus X rupees. So let the amount invested in first type is X rupees. Then that invested in second type of bond will be rupees 30,000 minus X rupees. First person X, then automatically second person 30,000 minus X. Why? Because the total amount is 30,000. Now first one, according to the given condition, the total interest both the trust pays 1800 rupees. So according to the given condition, matrix multiplication. So first amount is X, second amount is 30,000 minus X. These two terms forms one matrix, and interest for matrix multiplication, number of columns is equal to number of rows. Two columns, 2 rows. That equals to 1800. This is single matrix, one by one matrix. Now multiply these two matrices. X into 5 by 100 plus 30,000 minus X into 7 by 100, that equals to 1800. This is the rule condition. Now 5x by 100 plus 3 7s are 21, that means 2,10,000 minus 7x by 100, that equals to 1800. Now this is one by one matrix, this is also one by one matrix. Add, equate both the matrices. First, before equating this matrix, you take here LCM 100 5x plus 2,10,000 minus 7x by 100, that equals to 1800. So now take cross multiplication, and 2,10,000 next minus 5x minus 7x, that is 2x, that equals to cross multiplication 1800, that is 1,80,000. Now 2,10,000 minus 1,80,000, that equals to 2x. So 80 10, that is 30,000, that is 2x. Now x equals to 30,000 by 2, then x equals to 15,000. So the first bond invested, first type of bonds invested that is 15,000 rupees, and second bond, that is 30,000 minus X. That means this is first bond, second bond. So 30,000 minus X, that is 30,000 minus 15,000. That equals to 15,000. Hence, the amount invested in two types of bonds are 15,000 and 15,000. Both the 15,000 and 15,000 and 15,000. Similarly, in second bit, B bit, if the interest is 2,000, if the interest is B bit, if the interest is 2,000, then according to the given condition, X into 30,000 minus X, that equal into 5 by interest 100, 7 by 100, that equals to 2,000. Now multiply these two matrices, 5x by 100 plus 2,10,000 minus 7x by 100, that equals to 2,000. Okay, next, same process, 2,10,000 minus 2x minus 7x plus 5x minus 2x, that equals to 2,000 into 100, that is 2 lakhs. Now minus, that equals to 2x, then x equals to 10,000, then x 2x equals 10,000, then x equals to 10,000 by 2, then x equals to 5,000. Therefore, the amount invested in two types of bonds are respectively 5,000 and 30,000 minus 5,000, that equals to 25,000. So in first bond 5,000 invested and second bond 25,000 invested, because total amount is 30,000. Next, similarly, the next question is, the two types of the bookshop of a particular school has 10 dozen chemistry books, 8 dozen physics books, 10 dozen economics books. Their selling price are 80 rupees, 60 rupees and 40 rupees each for each subject. Find the total amount of the bookshop will receive from selling the books using matrix algebra. So 20th question. The number of books, let A equals to number of books. The chemistry books is 10 dozen. 10 dozen means 10 into, for dozen 12 books. So total number of books of chemistry 10 into 12. And physics 8 into 12. Economics 10 into 12. So A equals to 120, 96, again 120. And the cost of these books are, each book 80 rupees, 60 rupees and 40 rupees. So if you want to multiply these two matrices, number of column is equal to number of rows, so you can transfer this matrix, that is 80, 60, 40. B. Cost. Now total cost. Total cost means 120, 96, 120 into 80, 60, 40. That equals to row column. So 120 into 80 plus 96 into 60 plus 120 into 40. That equals to 120, 8 to the 96, 9600 plus 96 into 6, 5760 plus 120 into 40, 12 4 48, 48 into 100. The total cost is, at these three terms, you will get 20,160 rupees. So that is the total cost, 20,160 rupees. Next. So remaining two questions, you can do the homework.